All right, kids. Today what we're going to do is we are going to introduce topic 2.3, which is solving addition and subtraction equations. Okay, a couple things for you to remember. All right, number one, the example problems will be mostly easy. This way you develop good habits for solving equations properly. Number two, even though you can solve many in your head, always set them up and show the steps. This catches any little mistakes. Another thing to remember, number three, the goal is to get the variable alone. Setting up the layers shows this important concept, okay? So a couple things I want you to remember is that the example problems will be easy. And that's so that you develop good habits for solving equations, okay? Good algebraic habits, because they'll get complicated soon. Number two, even if you can solve these in your head, if you set them up and you show the steps, that will be a great way for catching those silly little mistakes that we seem to make in math sometimes, okay? And then the third thing is, remember, our goal is to get that variable alone. And when we're setting up those layers, which we think might be a waste of time, actually is reinforcing the whole process and showing you how important the concept is and how it works. All right? So anyways, we're going to go on and we're going to do Nearpod number one. Why do you need to actually do and show the steps when solving mostly easy equations? I'm going to pause the video. If you're at home and not doing Nearpod, use this pause to try and answer that question. Alrighty, here we go. Well, the reason that we actually do and show the steps when solving a simple equation is because we want to develop good algebraic habits and good algebraic skills. Because once we leave 6th grade, we're going to move into our secondary math, and we'll want those skills in place for the very difficult calculations we get in those grade levels. All right? Okay, well, let's actually look at this process, okay? When you solve equations, you will use the properties of equality to isolate the variable. In other words, when we solve an equation, we're trying to get that variable by itself, okay? So let's take a look at this and try it using Nearpod. All right, our first equation that we want to solve for is 22 equals 13 plus x. Why don't you pause the video right now at home, and I'll do it in school and see if you can come up with the answer or the value of x. Alrighty, let's take a look at what we have. The first thing you want to do is write down the original equation. So notice that I took 22 equals 13 plus x, and I wrote it down completely original and new. That's a really important thing to do. All right, the next thing that you'll probably do is create your layer where you bring in the inverse operation of this addition right here, okay? So right now, we're doing the addition of 13 to x, all right? So what we want to do is, instead of adding 13, we want to subtract 13, all right? So in order to do that, we're going to bring down the parts of our original equation. Okay, so you can see that we brought down the 22, we brought down the 13, we brought down the addition of x, but because of the commutative property, we can switch things around and say, well, we're adding 13. Okay, so that means we're going to have to do the inverse of 13. Okay, so what we did then is we then put in a minus 13 or a negative 13. So now we have a positive 13 with a negative 13, which will take us down to x by itself. Because what happens is, when you take this 13 right here and you add it to that 13, negative 13 added to positive 13 takes you back to your x, okay? So in other words, 13 take away 13 leaves you with x, okay? Which is kind of a neat way of looking at it, okay? Then on the other side, of course, you do the 22 take away 13, or if you have a positive 22 and you give it a negative 13, you're going to go back down the number line and you're going to end up at 9, because 22 take away 13 is 9. So in this case, you can see what we did here. You can see how we took our original equation, and we saw that we could use the commutative property and reverse things and think of it as adding 13 to x. So the inverse of adding 13 is subtracting 13. Okay, so what we wanted to do next was we wanted to bring down our parts of our equation, and then we wanted to subtract 13 from both sides. That left you with 9 on one side and x by itself on the other. Now what we want to do is we want to plug it in and actually see if our solution works. So what we're going to do is we're going to take this 9, which should be the value of x, and we're going to plug it into our original equation, okay, and see if it works. And in this case, we can see that 13 plus 9, and if we actually did the math and we did 13 plus 9, we could actually say, okay, that equals 12, regroup, 1 plus 1 is 2, so that gives you 22. And so it does balance. And that's why we have this little teeter-totter image there for you. All right? Okay, let's take a look at another example. Okay, Nearpod 3. So if you're at home, pause the video and see if you can do this. In school, we're going to try it as well. And here is the equation. And it is 12 equals x minus 11. Pause the video and see if you can solve that, showing the steps. Okay, kids, here we go. All right, the first thing that we'd want to do is we'd want to set it up to solve, okay? So what we would do is we would bring down our original parts. We have 12, and we have x, and we have take away 11 or negative 11, okay? And what we want to do is the inverse operation of subtracting 11, which means we're going to add 11. But we're going to make sure that we add 11 to both sides of the equation. So in this case, when we do that, we would see that we get x by itself because over here, this negative 11 or minus 11 is, we get rid of it by giving it a positive 11. So if you subtract 11, you add 11 to it, it leaves you with the x by itself. Okay, so then what we do is we know that we have to go to the other side and we have to do 12 plus 11. So if we do 12 plus 11, you'll see that we have 2 plus 1 is 3, 1 plus 1 is 2. So the value of x should be 23. Now we want to check that. So we would want to actually do the math and see if that works out. So we would then say, okay, well then let's take 23 and let's subtract 11 and see if we do get 12. 3 take away 1 is 2. 2 take away 1 is 1. So our answer actually does work when we plug the value of x in, which we think is 23. Okay? All right, let's try another example. But this time we're going to kind of reach back to what we did yesterday. All right, Nearpod number 4. Okay, if 7t equals 70, does 12 times 7t equal 12 times 70? So in other words, if you know that 7, the coefficient 7, times some unknown number equals 70, does 12 times 7t equal 12 times 70? Explain your answer. You can pause the video if you haven't and explain it. Alrighty, here we go, kids. Let's take a look at the answer. The answer is yes, because each side is multiplied by the same number. So in other words, if we get rid of all of that and we look at what we have in common here, you'll see that first of all, you have 7 times some unknown number equals 70. We might not know what the value of t is, but we do know that it equals 70. So then we say, okay, well, if we have 12 and we multiply it by 7t, we're actually multiplying it by 70. So on the other side of our equation, okay, the equal sign, we see that we have 12 times 70. And so, in other words, this is a balanced equation. We don't have to know what the value of t is, but we do know that 7t and 70 are equal. So in this case, you can see that the 7t and the 70 are actually giving you the same value. And you're doing the same thing on both sides. You're multiplying, okay? Alrighty, let's take a look at another one. Nearpod number 5. If, whoops, let's get rid of that. Nearpod number 5. If 12 minus 8 equals 4, does 12 minus 8 divided by 2 equal 4 multiplied by 2? Pause the video and explain your answer. Alrighty, here we go, kids. The answer in this case is no, because one side is divided by 2 and the other side is multiplied by 2. Okay? So in other words, when we look at this, you can see that in our original equation we have 12 minus 8 and then we divided by 2. On the other side, we had 4 times 2 and that was just it by itself. But you can see that we have multiplication over here instead of division. Okay, so they will not equal. Even if you have 12 minus 8 equals 4, it just doesn't work. Okay? All right, so anyways, that's it. If you have any further questions or other concerns, you can ask them now in class, or you can send me a message on Schoology. All right, have a good day, kids.